So here the next topic in acids and bases and salts chapter, that is reactions of acids and bases with metals. One thing what you have to understand here is, if you take an acid or if you take a base as a substance, these acids and bases they usually have the tendency to react with metals. If they react with metals, then what kind of reaction is possible for both acids and bases when they are reacting with metals? Let us observe. For example, if you are taking an acid, say for example if HCl is an acid, say it is reacting with a metal, that is zinc is a metal, solid, it's a metal. As it reacts with metal to give rise to, that is aqueous, it gives rise to zinc chloride aqueous plus hydrogen gas. What you need to understand here is, if the hydrochloric acid aqueous, if it is dilute, then the liberation of hydrogen takes place very slowly. If the hydrochloric acid, if it is concentrated, then when it is reacting with the metal zinc solid, it is going to liberate the hydrogen gas vigorously. A very fast reaction takes place and the liberation of hydrogen gas is instantaneous. So for example, that's why here one thing what you understand is, once again I am reminding this, if the hydrochloric acid aqueous, if it is dilute, then liberation of H2 gas liberated is slow. If you take the same HCl aqueous, if it is concentrated and if you dilute, it is the liberation of hydrogen gas is slow. If it is concentrated, hydrogen gas liberated is very fast. One of the point which you have to keep it in your mind. Likewise, if you go for a base, that is NaOH is a base, then when it is reacting with the zinc as a solid metal, it immediately gives one salt, that is Na2ZnO2 plus liberation of hydrogen gas takes place. This is called sodium zincite. The salt name which we call here it as sodium zincite. It is a salt, it is sodium zincite. Here also it is a salt, that is zinc chloride. So here also the same thing applies for even the base also. If the base is a dilute, then the liberation of hydrogen gas is low, and if the base is concentrated, then the liberation of hydrogen gas is vigorous or fast. Okay, the next part of the discussion here is reaction of acids, with the carbonates and metal bicarbonates. Reaction of acids with the carbonates and metal bicarbonates. That is, if you take one example, according to the side heading, you take an acid, that is HCl aqueous. Because we are saying carbonates, I will take sodium carbonate aqueous, and immediately the sodium carbonate, when it is reacting with the hydrochloric acid, that is acid, it is going to give, that is NaCl sodium chloride aqueous plus carbon dioxide gas plus H2O liquid. Similarly, if the same HCl, that means reaction of acid with carbonates is completed. Now reaction of acids with the metal bicarbonates, that means if I take the same HCl aqueous and if I am making it to react with the sodium bicarbonate aqueous, sodium NaHCO3, sodium bicarbonate. This is metal is sodium, bicarbonate is HCO3 is bicarbonate. So sodium bicarbonate reacts with an acid again to give, of course in the earlier equation also, if you need to balance the equation, take 2 over here besides sodium chloride, and number of hydrogens also I think we have to balance it, take 2 here, the reaction is balanced in the first equation. But if you go to the second equation where the acid is reacting with the metal bicarbonate, when an acid reacts with metal bicarbonate, of course you are going to get sodium chloride plus carbon dioxide plus water. As usual, liquid, carbon dioxide is a gas and sodium chloride is aqueous. I think the reaction is already balanced because there are 2 hydrogens here, 2 hydrogens, 1 oxygen plus 2 oxygens, 3 oxygens, then 1 carbon, then 1 sodium and 1 chlorine. The entire reaction is getting balanced here. What is interesting here is you take this carbon dioxide which is obtained in both the reactions, you take this carbon dioxide and you treat it to a metal carbonate, that is you can treat it to the calcium carbonate and you can also treat it to, that is calcium hydroxide, and let us see what kind of reaction is going to take place when the carbon dioxide is reacting with again the other metal carbonates and metal hydroxides. So here the obtained carbon dioxide in the previous case is treated with the, that is calcium hydroxide is a base, it is a base and it is also called as, that is slaked lime, or we can simply call it as calcium. So this calcium hydroxide, that is base, this slaked lime or calcium hydroxide, that compound is treated with, that is aqueous, treated with carbon dioxide gas, it gives a new compound calcium carbonate aqueous plus water liquid. Mind you, this is a salt. From base by treating with carbon dioxide you are getting a new salt, that is calcium carbonate, that is limestone, or calcium carbonate which is salt, and again water is liberated. Now take this calcium carbonate aqueous, again you pass some more amount of carbon dioxide gas and you add sufficient amount of water liquid, then you get a bicarbonate CaHCO3 taken twice. Check out the balancing of the equation. Check out the balancing of equation, that is you can see that there is one calcium, there are 2 hydrogens, 3 to the 6 oxygens. So therefore here a salt, okay, when it is reacting with carbon dioxide in the presence of water, it is giving again, that is metal bicarbonate. That metal bicarbonate is nothing but calcium bicarbonate. The obtained calcium carbonate is actually a white precipitate, but once the calcium bicarbonate is formed, okay, it is a soluble salt in water. These 2 points we have to keep it in our mind. Calcium carbonate is also called as milk of lime. That is slaked lime is calcium hydroxide, slaked lime is calcium hydroxide, calcium bicarbonate, and CaCO3, that is limestone, it is also called as milk of lime because it is in the aqueous state. After this topic, after the completion of the reaction of acids with the salts and the reaction of carbon dioxide with the carbonates, now we are going to the next topic, that is neutralization reactions of acids and bases. Neutralization reactions of acids and bases. What do you mean by a neutralization reaction? The meaning of neutralization reaction is when 1 mole of acid which contains 1 mole of H plus ion and 1 mole of base which contains 1 mole of OH minus ion to give a salt, to give 1 mole of salt, 1 mole of salt, where the H plus ion, 1 mole of H plus ion and 1 mole of OH minus ion of acid and base, they interact with each other and give a neutral molecule, salt plus water, salt plus water plus sufficient amount of energy is also released. So therefore we can say that all neutralization reactions are exothermic in nature, that is energy is lost. Take one example for neutralization reaction, that is generally here we take acid, means you can take different combinations. You can take strong acids and weak acids, strong bases and weak bases. For example, if I take acids are of two types, strong acids and weak acids. Strong acids SA, weak acids WA. Similarly, go for bases. If you go for bases, weak base, that is strong base, strong bases and weak bases. Strong acids, you can take plenty of examples, HCl, HNO3, H2SO4, H2SO4 are all strong acids. Weak acids, you can take plenty of examples. Acetic acid is the best example of weak acid. H2CO3, carbonic acid is the best example of weak acid. You can take, apart from this, you can take H3PO4. Phosphoric acid is also a weak acid. If you go for strong base, that is NaOH, KOH, barium hydroxide, all these are the examples of strong bases. What are weak bases? Weak bases are, that is ammonium hydroxide, silver hydroxide, aluminum hydroxide, all these are the examples of weak bases. So if that is the case, then you can take any combination, you can take, that is I am taking strong acid, HCl aqueous reacts with, this is strong acid, reacts with the strong base, that is NaOH aqueous, this is strong base, interacts to give, an acid is reacting with the base to give a salt, NaCl aqueous plus H2O liquid plus energy. This reaction clearly depicts how the reaction is taking place between an acid and a base in the neutralization reaction. Always in the neutralization reaction, acids furnishes H plus ions and bases furnishes OH minus ions. The H plus ions of an acid and the OH minus ions of a base, they interact with each other to form unionized neutral molecule, that is water molecule, and it also gives us 1 mole of, that is salt, sodium chloride. So this is neutralization reaction, and neutralization reaction is an exothermic reaction.